Hello, welcome to this video. In this video, let us take few problems on Otto cycle. Now, the minimum pressure and temperature in an Otto cycle are 100 kilopascal and 27 degrees Celsius. Now, our first duty is to draw PV as well as TS diagram for an Otto cycle. So, the moment I see that the given problem is of Otto cycle, the first thing I do is I draw PV as well as TS plot. Okay. So, we have a reversible adiabatic compression, then constant volume heat addition, and then here we have constant volume heat rejection and reversible adiabatic expansion. Okay. So, this is our 1, 2, 3 and 4. Okay. So, 2 to 3 is where we are adding heat, 4 to 1 is where we are rejecting heat. Similarly, on TS plot, we have constant volume, constant isentropic processes represented like this. Okay. So, 1 to 2 is isentropic compression or reversible adiabatic compression, that is PV power gamma is equal to constant here. 2 to 3 is constant volume heat addition, and 3 to 4 is constant isentropic expansion, reversible adiabatic expansion, and 4 to 1 is constant volume heat rejection. Okay. Now, this is our reversible adiabatic expansion 3 to 4. Now, the minimum pressure and temperature, the moment I see minimum pressure and temperature, it happens at, we can see it here, the first point is the minimum pressure, right. The point 1 is where the minimum pressure is. So, P1 is given 100 kilopascal. So, 100 into 10 power 3 Newton per meter square. So, kilopascal to pascal is 10 power 3, and temperature, the moment it is given, convert this into Kelvin. So, 27 degrees Celsius. So, 27 plus 273 is 300 Kelvin. The amount of heat added is given. So, 1500 kilojoule per kg. So, Qs is given, per kg is given. So, mass is not given, I think. So, per kg. So, for every kg of air which we are circulating here, the amount of heat which I have to supply is 1500 kilojoules. Now, the question is determine pressure and temperature at all points. That is very fundamental question. In any given problem, this is what we will have to find out. So, we will have to find out pressure and temperature at all salient points. We will have to find out pressure and temperature at all points. That is what we need to find out first. Then sub question B also calculate specific work. So, work we will have to calculate, thermal efficiency we will have to calculate, and for the compression ratio is 8. So, the value of compression ratio is given 8, and CV for air is known to us 0.718 kilojoule per kg, or he has given us so 0.72 kilojoule per kg Kelvin, and gamma value for air is also known to us, but it has been given 1.4. Now, efficiency can be readily found out because the moment I have compression ratio, efficiency is 1 minus 1 by R power gamma minus 1, correct. So, that will come back. So, our first task is to find out pressure and temperature at all salient points. Now, let us start finding out pressure and temperature at all salient points. Now, I will use this P1 V1 power gamma. So, we will go one by one. So, we will use process 1 to 2. Now, 1 to 2 is what? P1 V1 power gamma is equal to P2 V2 power gamma, correct. So, we can say P2 is equal to P1 V1 by V2 whole power gamma, and remember V1 by V2 is R. So, we can write it like P2 is equal to P1 V1 by V2 is R. So, R power gamma. So, P1 is 100 into 10 power 3 and the compression ratio is 8. 8 power gamma is 1.4. So, we can find out the value of P2. So, the value of P2 is 100 into 10 power 3 multiplied by 8 power 1.4. So, that will be 1.83 into 10 power 6, 1.83 into 10 power 6 Newton per meter square. Okay. So, that will be our P2. Similarly, let us go for T2. Now, how do we find out T2? Now, similar expression can be used. Similar expression can be used. The same process 1 to 2, between same process 1 to 2, I would like to use, I mean, I want a temperature ratio, not pressure volume relationship. I will go for temperature ratio. Now, how do we do that? That we have done it plenty of times. Now, PV is equal to MRT expression I will use. Okay. So, I want to eliminate volume, sorry, pressure. So, if I want to eliminate pressure, it has to be MRT by V. Okay. So, MR will get cancelled out. So, in place of pressure, I need to use temperature ratio. So, T1 by V1. So, V1 power gamma, T2 by V2, V2 power gamma. So, that means T1 V1 power gamma minus 1 is equal to T2 V2 power gamma minus 1, or simply we are saying T2 is equal to T1 V1 by V2 whole power gamma minus 1. That means T2 is equal to T1 R power gamma minus 1. Now, T1 is known to us 300 Kelvin and R is known to us 8 compression ratio and gamma minus 1 is 1.4 minus 1, that is 0.4. So, that will give us the value of T2. Let us solve this. 300 into 8 power 0.4. So, 689.219. So, T2 is equal to 689.219. So, now we have found out the value of P2 and the value of T2. Okay. Now, let us go to the maybe we will go to 2 to 3. Now, similarly, we can go for process 2 to 3. Now, what is process 2 to 3? Process 2 to 3 is heat supplied. Now, heat supplied is given to us, and for heat supplied we know the equation for a constant volume mCV dt. mCV that is T3 minus T2. So, T3 minus T2. All right. Now, this m is here, I mean per kg it is given, so that is nothing but Qs by m is equal to Cv T3 minus T2. Now, Qs by m is given, that is I am saying that joule per kg, right, 1500. Now, we can balance the unit here. This side if you substitute it in kilojoule per kg, this side also it has to be kilojoule per kg. So, kilojoule per kg Kelvin if you substitute and temperature in Kelvin, then it is balanced. All right. Otherwise, if you want to substitute in joules, it is okay, but both the side it has to be in joule. So, this is 1500 is given. Now, Cv is 0.72 is given, T3 is the unknown and T2 is 689.219. All right. Now, the only unknown is T3, that is the maximum temperature in the cycle, we can find it out. Okay. So, 1500 alpha equals 0.72 into the unknown, we will call it as alpha x minus 689.219. So, we will shift solve for x is equal to 0, 2772.55, 2772.55, 2772.55 Kelvin. So, temperature is found out. Now, similarly, Now we have got P1 T1, P2 T2, T3. How do we find out P3? Now let us find out P3 similarly. Now to find P3, so this was to find T2, all right. To find P3, we can use between volume constant, right. So the process 2 to 3 is volume constant. So 2 to 3 is volume constant process. For volume constant, what we can write? PV is equal to MRT expression we can use. Now volume constant means I will send this volume to the right side and temperature to the left side. So P by T is equal to MR by V. So the whole right side is constant because mass is constant, R is constant for a closed system. So volume is also constant. So P by T is equal to constant. That means for process 2 to 3 we can write P2 by T2 is equal to P3 by T3. All right. Now I think we know P2 1.83 into 10 power 6. T2 we know 689.219 and P3 is the unknown and we know T3 is 2772.55. The only unknown is P3. Now let us find out the value of P3. So 1.83 into 10 power 6 divided by 689.219 alpha equals the unknown alpha x divided by 2772.55. Now let us go for shift solve for x is equal to 0. We get P3 as 7.36 into 10 power 6. P3 as 7.36 into 10 power 6 Newton per meter square. Okay. Now the let us go for using 4 to 1 and try to find out the value of 4, P4 and T4 we are done. Okay. Now let us go for process 3 to 4. Now process 3 to 4. Process 3 to 4. P3 V3 power gamma is equal to P4 V4 power gamma. And we know that P3 is known to us. Now V3 by V4 I will take it here whole power gamma and that is what is P4. Now remember what is V3 by V4? V3 by V4 is 1 by R, right. So V3 by V4 you can write it here V1 by V2 is equal to R and V1 is equal to what? V4. V1 is equal to V4 and V2 is equal to V3, constant volume processes. So therefore V3 by V4 if you have it is 1 by R. So P3 1 by R whole power gamma is equal to P4. So therefore P4 is equal to, now P3 is 7.36 into 10 power 6 into 1 by compression ratio is 8 and gamma value is 1.4. So that will give us the value of P4. So 7.36 into 10 power 6 multiplied by 1 by 8 to the power 1.4. So that will give us the answer 400 into 10 power 3. So 400.45 into 10 power 3. 10 power 3 Newton per meter square. So P4 we have found out. Let us go for the same temperature and temperature ratio. This is what we can use. I mean, if you see here, T1 V1 power gamma minus 1 will be equal to T2 V2 power gamma minus 1. So, you can do this again between 3 and 4, or you can also use this like T2 is equal to T1 R power gamma minus 1. Similarly, T3 will be equal to T4 R power gamma minus 1. So, T3 is equal to T4 R power gamma minus 1. So, the same ratio will get T3 is equal to R, will do it again. So, the idea is the same. We will have to get the ratio between pressure and temperature and volume. So, same process to find T4. So, P3 V3 power gamma is equal to P4 V4 power gamma, and we know that we are eliminating pressure. In place of pressure, we can write MRT by V. So, that will be T3 by V3. V3 power gamma is equal to T4 by V4 power gamma. So, T3 V3 power gamma minus 1 is equal to T4 V4 power gamma minus 1. So, R, if you want T4, so T4 is equal to T3 V3 by V4 whole power gamma minus 1. Now, what is V3 by V4? V3 by V4 is 1 by R. So, that is what I said. So, T4 is equal to T3 1 by R whole power gamma minus 1. Now, what is T3? T3 we have found out 2772.55 Kelvin into 1 by 8 power 1.4 minus 1, that is 0.4. Okay. Now, let us solve this. 2772.55 into 1 by 8 whole power 0.4. So, 1206.82. 1206.82 Kelvin. Now, the whole idea of this solving this problem is, do we know how to calculate pressure, temperature and volume at each salient point, right? So, that is what we have done so far. Using the relationship between each processes, we have tried to find out pressure and temperature. Now, let us go to the sub question 2. Also calculate efficiency and work transfer, that is it. So, efficiency is readily available. The moment you have the compression ratio, we can find out this 1 minus 1 by R power gamma minus 1. So, that is an equation for efficiency of an Otto cycle. So, 1 minus 1 by compression ratio is 8 and this is 1.4 minus 1. So, that will be 1 minus 1 by 8 to the power of 1.4 minus 1, that is 0.4. So, that will be 56.47 percentage. So, of course, I am multiplying it by 100, 56.47 percentage. So, multiply it by 100. Now, the second part is work transfer. Now, efficiency is given by what? Work divided by QS. Now, efficiency we have calculated 0.5647, I will substitute. Okay. While substituting it back, make sure that we are substituting it like 0.56. But when you are getting multiplied by 100, because I am avoiding 100 each and every time here. So, work transfer is what we want and Q is 1500. And remember, we will get this in kilojoule per kg, because efficiency does not have unit. Whatever unit we write QS in, the same unit will be work transfer. So, the work transfer we can get in kilojoule per kg, that will be 0.5647 into 1500. 847.05, 847.05 kilojoule per kg. We will solve few more problems on Otto cycle in the next class. Thank you.